Welcome back, fifth graders, to day 2 of finding the volume of 3D composite shapes. Yesterday, guys, we spent time focusing on the formula for volume of a rectangular prism, reviewed that a little bit, and then we showed how we can use that formula to help us find an irregular shape. And an irregular shape is just something that is not consistent or has more than one piece to it. And that's what these composite shapes are for us. You can see that on today's problems that I have here in front of you, we've got two buildings. They are both the same types of problems we did yesterday, in a sense that they are two rectangular prisms that have been put together. The first one should be a relatively easy problem for the simple fact that none of the problem has a missing part. None of the building is missing or doubling up on any of the numbers that we have, so we shouldn't have to worry about what numbers we are plugging into our formula, which should make this a relatively easy problem in terms of composite shapes. None of them are super easy just because there are so many steps in the process, but at this point, this should be one of the easier ones. So I am going to take and draw a line and know that we are going to separate these two buildings, these two rectangular prisms, on this line right here. So that means we have a large building, which I'll mark as A, and we have a small building, which I will mark as a very bad arrow and a B. Okay, so I'm going to start with the large building first, guys, and I'm going to write down the formula and how I'm going to find that. Again, the volume formula for a rectangular prism is length times width times height, or the area of the base times the height. So however I want to look at that, but if I look at that situation, here is my length, here is my width, so I'm going to take 50 times 30, and I'm going to get that answer, which would equal 1,500. And then I'm going to multiply that by the height of the entire large building, which would be 12, and that is going to get me an answer of 18,000. So that is the volume of rectangular prism A right there, 18,000. Now, for rectangular prism B, smaller numbers, smaller rectangle or rectangular prism, so it should be easier based on that as well. But you can see rectangular prism B, we're going to start with, and I'll put it over here on this other side, the left side, I'm going to start with 5 times 10, which will get me to 50. And then I'm going to take that answer and I'm going to multiply it by 15. So after I do that, again, just go through the process here. Maybe not the easiest way I could have done this. I could have gone a different way, but still gets me to the same answer of 750. And I'm going to take now the volume of rectangular prism B and add that to rectangular prism A to end up with a total answer of 18,750. Really big numbers. Remember, you guys have access to your calculators for these types of problems. We are not expecting you to have to go through this entire process. The more important aspect of this, guys, is that we remember to label our answer correctly. So I've got my answer here, but then also I need to know that this is in meters, and we are talking in cubic units. So meters cubed, or if I want to write out the word cubic meters, that would be fine as well. I'm going to pause here for just a second while I erase the information that I have here, and then we're going to start in on problem 2, and I'm going to have you do a lot more work on problem 2. I'm just going to kind of set up the problem for you and get you to understand what it is we are looking for. All right, so after that pause, problem 2 is a little harder for multiple reasons, guys. We are looking at 3 parts. First of all, no real way that I can see that we can divide this building up into only 2 rectangular prisms. So the way I'm looking at it is if we take each of the different heights of the building and we make 3 separate buildings at those points right there, that is how we're going to have to try and solve this problem. So not only are we going to find one volume of a rectangular prism, not two volumes of a rectangular prism, but we are going to find three in this instance. And the numbers, again, are going to be quite large. Okay, so I will mark these building A, building B, and building C, just so we know what we are talking about right now. I'm going to set up the problem, but I'm not going to actually solve it. I want you to answer that question, and I will put an exit ticket or a single question to help you answer this problem right after this video. So please make sure you click onto the exit ticket when you are done watching this video. So volume A, or the volume of building A, is going to be the area of the base, or length times width, which is 20 times 25, and then times the height. In this case, that building height is 30 feet. So that is building A. And hopefully you can all see where those numbers came from and how that all works out. Now we do see a 20 with building A, but that is not helping us with building A. That's actually helping us with building B. So as I look at building B, they still give me a length. They still give me a width, only because I'm able to determine that each of those sides are the same width across, 25, 25, and 25. And we also know that the width is 20 and the length is 25. So as I look at building B, I should be able to very easily see that the 20 by 25 is still the same. And the only thing that we are going to be changing in this process, guys, is the height of building B. But it doesn't tell us that right off the beginning, right off the top. There is no number that just says, here's what it is. We do know that the height of building A is 30, and we do know that the height from the roof of building B to the top of building A is 20. So what I need to do in that instance is kind of like we did yesterday. We need to subtract to find the difference between those two numbers, and that will tell us the height of building B. In that case, 30 minus 20 is 10. So that is going to be our formula for building B, or that is going to be our problem we need to solve for finding the volume of building B. And the last one then, again, back to a relatively straightforward gathering of information. Building C is going to be, again, same area of the base, 20 times 25. But here again, they do tell us the height of this building right here, which is also 20. So you can see a lot of numbers, you can see a lot of things that need to be multiplied, and you can see the reason why we're allowing you to use a calculator to try to solve these problems. When you try to solve the brain game problem, or try to solve this problem as the brain game, I will put and capture this entire image on the brain game. But when you try to solve that problem, guys, I am going to make you label your answer as well. So be aware that this will be one of the first brain games in a while where I will ask you to label your answer. All right, thank you guys for paying attention and going through those couple of problems. We will probably have a third day of lessons for this very difficult task, so be aware that tomorrow's lesson will probably be the same thing. Thank you very much, and don't forget to do the brain game.